Notes 2.9 are on rates of change in polynomial functions, and I have a feeling that this is going to be a little bit of a lengthier video, so please make sure that you are in a really good mindset and able to concentrate on what we're talking about, because this is a lot of really important information with regards to rates of change. So number one, it says the graph of a polynomial function is shown below. Estimate the instantaneous rate of change in f of x at the point 2, 0. So I want to find what my rate of change is going to be right here. Well, in order for me to be able to do that, I have to find my equation. So that's what I'm going to start off by doing. So I know that I have roots at x equals 0, at x equals 2, and at x equals 4. This one has a multiplicity of 1. This one has a multiplicity of 2, and this one has a multiplicity of 1. So I know that I'm going to start off with a function that says f of x equals some type of a value times x minus 2 to the power of 2, because it has a multiplicity of 1, times x minus 4. Okay, and then I'm going to go ahead and evaluate and figure out what my a value is going to be right here. Now, in order to calculate what my a value is, I need to choose a coordinate on my graph. So I know that 1, 3 is a point on my graph, so I'm going to plug in that information. So I'm going to say 3 equals a times 1 times 1 minus 2 squared times 1 minus 4. Okay, so put a 1 here and a 1 here, and then I'm just going to evaluate. So you get 3 equals a times 1 is just a times negative 1 squared times negative 3. So I end up getting 3 equals negative 1 squared is 1 times negative 3 is negative 3. So I get 3 equals negative 3a, which means that a is equal to negative 1. Well, if I know what a is, I can figure out what my function is. I know my function is just going to be negative x times x minus 2 squared times x minus 4. And this is going to be very useful to me. Okay, now that I know what my function is, I can figure out what my instantaneous rate of change is going to be. So in order to figure that out, I'm going to use, to find my IROC, I'm going to use my formula. So my IROC is going to be delta y over delta x. And if you remember, there's a lot of different ways to do it, but we're going to use f of x plus h minus f of x all over h. And in this example, our h value is going to be 0.01. Okay, remember we want smaller h values if possible. So right here, when I do this, I'm going to have f of, we know our x value, we want it to be at 2. So we're going to do f of 2 plus 0.01 minus f of 2 all over 0.01, because that's what h is. So that's what my instantaneous rate of change is going to be. So basically, I'm just going to do my instantaneous rate of change is f of 2.01 minus f of 2 all over 0.01. So then I'm going to go ahead and evaluate that and see what I end up getting. To use my Inspire to calculate these values. So the first thing I'm going to do is I'm going to type in, I'm going to store let me minimize this. I'm going to store 2.01 in as x. So control store as x, press enter. Once I've done that, then I'm going to type in my function, well, the expression piece of my function right here. So negative x times x minus 2 squared times x minus 4. So negative x times x minus 2 squared times x minus 4. And don't forget to put your multiplication signs in between them when you're using the Inspire, so that way it knows what you're talking about. So I get 0.0004. Okay, so right here, I end up getting 0.0004 minus, I'm going to do the same thing, but this time I'm going to store 2 in as x. So 2 stored in as x, I'm going to go up and highlight, press enter, enter, and I get 0, which should make sense because A, it tells us that it's at 2, 0, and B, we have a root at 2. So this means that f of 2 is going to be 0, and that's all going to be divided by 0.01. Well, I end up getting 0.004 over 0.01. And when I divide those two values out, I end up getting, let's see, 0.004 over 0.01, I end up getting 0.4, which is a pretty small value. So, and remember, these are all estimates, so it's not exactly right, because you can't find the answer unless you're using calculus. So we're going to say basically that it's the IROC, the instantaneous rate of change, is basically equal to 0. It's small. There's no rate of change. And that should make sense to you, because when I take a look at my graph right here, it's flat. The slope of my tangent line, my line that's tangent to the graph at 2, should be 0. So if you notice, this is a turning point, has a slope of 0. Anywhere along this part of my graph right here, since my graph is increasing, my rate of change is positive. Okay, so here my instantaneous rate of change on this part of my graph is going to be positive. Here it's 0. Here it's negative. Here it's 0. Here it's positive. Here it's 0 again, and here it's negative. So not only does the instantaneous rate of change tell us which way our graph is going, but it tells us where our turning points are going to be. So if I have an instantaneous rate of change of 0, that tells me, oh, I've got a turning point for my function at this point in time right here. Okay? What conclusion can we make regarding our instantaneous rate of change? We can say that the instantaneous rate of change tells us when our graph is increasing, and if it's increasing, then our IROC will be positive, so we'll say it's a positive IROC. When the graph is decreasing, and our graph will be decreasing when we have a negative IROC, or when our graph has a turning point. So we'll say, or when our graph has a turning point. And if we have a turning point, then our IROC, or our instantaneous rate of change, is going to be equal to 0. Okay? All right, so now let's see how we can apply that to question number 2. So it says, consider the function f of x equals x squared plus 5x minus 6. And question A says, find an equation that will tell you the instantaneous rate of change at any given value of x. So I'm going to find an equation that's going to tell me what's my rate of change no matter what my x value is going to be. Well, this is just going to require a lot of algebra, so make sure you guys are paying really close attention to what we're doing here. So to find rate of change, to find instantaneous rate of change, you have to do change in y over change in x. And like we said, we're going to do f of x plus h minus f of x all over h. Now, in order to be able to do this, I need to think about what my function is. So if my function is x squared plus 5x minus 6, what this f of x plus h here is saying is every time I see an x, I'm going to replace it with x plus h. So what this is saying is I'm going to do x plus h squared. That's this x squared piece right here, plus 5 times x plus h minus 6. That's what f of x plus h is. Okay, just like if I wanted to figure out what f of 2 is, I would plug in 2 every time I see an x. Okay, so then once I do that, the next thing I'm going to do is I'm going to subtract what my actual f of x value is. So my f of x expression, is x squared plus 5x minus 6. Okay, and that's going to be all over h. So now that I've done that, I just have to do a lot of algebra. So what I have to figure out, well, what's x plus h squared? Remember, x plus h squared means x plus h times x plus h. So when I multiply this through, I get x squared plus xh plus another xh plus h squared. So this gives me x squared plus 2xh plus h squared. So putting that all together right here, I end up getting x squared plus 2xh plus h squared. And then I'm going to distribute this 5 through. So when I do that, I end up getting 5x plus 5h and then minus 6. Okay, and then I need to distribute this negative through right here. So I end up getting minus x squared minus 5x plus 6. And this whole thing is going to be over h. Now, one thing that I forgot to say that's really important is we're trying to figure this out for small values of h. That's really important. We actually, if we can get h to be 0, that would be perfect. So we're actually going to look for something called a limit as h approaches 0. That's what we're going to do. But right now, I can't divide by 0 right now, because when I divide by 0, I'll get an undefined answer, so I don't have any information right here. And that's why we have to do all this algebra here to help us figure out, well, what's this answer going to be? If we can get a simplified answer where I don't have an h in a denominator, so much easier for me to solve, okay? So let's take a look at what we have here. If you notice, we have an x squared here, and we have a minus x squared here. Those are going to cancel each other out. Okay, I also have a 5x here and a minus 5x. Those will also cancel each other out. And then I have a minus 6 and a plus 6, and those will also cancel each other out. So that means that right here, I can technically say that it's equal to the limit as h approaches 0 of 2xh, that's what I have here, plus h squared. I have a 5h here, all over h. Okay, so now if I take a look at this right here, I end up looking and I can see, well, you know what? I have an h in common with all of my terms up here. So I'm going to factor an h out. So I get 2x plus h plus 5 all over h. Well, my h's can cancel out. I have no h's left over. So I've got the limit as h approaches 0 of 2x plus h plus 5. Well, once I look at that, I don't have to worry about dividing by 0. I can plug 0 in right here for this h. So this 0 can go in for this h. So I end up getting 2x plus 0 plus 5, or just 2x plus 5. So this right here is going to be my instantaneous rate of change at any point. So if I say find the instantaneous rate of change when of this function when x is 8, for example, then I would do 2 times 8 plus 5. So I would get 16 plus 5, which is 21. So if I were to graph it out, I would know, oh, the slope of my tangent line when x is 8 is going to be 21. Okay? So now that I figured out what my instantaneous rate of change is going to be for any value of x, I'm going to use the equation to find the turning point of the function above. Well, if I want the turning point, I figured out earlier that my instantaneous rate of change has to be equal to 0. So instead of saying my instantaneous rate of change right here, I'm just going to use 0, and then I'm going to say 0 equals 2x plus 5. Okay, so then when I solve this equation right here, I get negative 5 equals 2x. So therefore, I get negative 5 over 2 equals x. That's where my turning point is. So my turning point occurs when x is negative 2.5. But the question is, right here, what is my y value? Well, how do I find that? All I have to do is find f of negative 2.5. So let's go ahead and do that. So right here, I'm going to take negative 2.5 and I'm going to store it in as x. Okay, or I could just plug in my information, whatever you want. Okay, so negative 2.5. Store it in as x, and then my function says x squared plus 5x minus 6, so I'm going to type in right here x squared plus 5x minus 6, press enter, I end up getting negative 12.25. So therefore my instantaneous rate of change, my point is going to be negative 2.5, negative 12.25. So this right here is going to be my turning point. Now the question is my turning point a minimum or a maximum? Well, there are several different ways I can do this. But I'm going to show you a new way to do it, and then we're going to confirm with the method that you guys already know. So at negative 2.5, I know my rate of change right here. If I were to put this on the number line, I know my rate of change is 0. But before negative 2.5, my rate of change, I don't know what it is. So what I'm going to do is I'm going to use my rate of change formula, which is 2x plus 5. Okay, and before negative 2.5, I'm going to choose any x value. So I'm going to test a value. Let's test negative 3. So when I do this, I'll get 2 times negative 3 plus 5. So I get negative 6 plus 5, which is negative 1. So therefore, my instantaneous rate of change before negative 2.5 is negative. Okay, but let's test a value after 2.5. So let's test or negative 2.5. So let's test 0. So right here, when I do this, my instantaneous rate of change after negative 2.5 is going to be 2 times 0 plus 5. So I get 0 plus 5, which is 5, and that's a positive value. Okay, therefore I can see that my graph is going to be decreasing here. It turns here, and then it's going to be increasing here. So therefore my graph will look like this, which should make sense to you because we know that we have a, let's look right here, we have a parabola. And the leading coefficient is positive, so we know that our parabola is going to open up. Okay, so therefore we can say that this turning point right here is also our minimum. And now you know how to figure out what the turning point is in a graph using your instantaneous rate of change. Okay, I promise you once you get to calculus, it's so much easier to find this stuff out. But for right now, we don't really have the tools yet, so this is the only way that we can figure this out. Okay, all right, I'll see you next class.